Hello, ma'am.
Good evening, sir.
Yeah, ma'am. Good evening, ma'am.
You can continue.
Okay, ma'am. Ma'am, make me. Yeah. Ma'am, make me a host.
Yes, sir. You can continue, sir.
Good evening, sir.
Yeah, Ajay. Good evening. Where is the other two, Dhanalakshmi, Ritika?
Sir, they have exams this week.
Yeah.
Anushri, Ritika, and Dhanalakshmi, three of them.
Okay.
Okay, they will join after a week, sir, after Diwali.
Okay. Anyways, we'll continue, ma'am. For the other new students, I don't know whether you have attended the class. We're doing the chapter Chemical Kinetics. We have done one session last week. So we'll have to continue from where we have stopped. Ajay, we did work. Any problem last class? Did we work any of the problems? Did we work any problem?
Sir, yes, sir.
Yeah, around 5 problems I think we have worked.
Yes, sir. Just some few, sir. The starting, some you finished, and then you said you'll do the rest next class.
All right, we will continue with that and then continue with the topic. Now, for the people who are new and who have joined today, we'll have to understand a few concepts. Based on this only, we are going to work out some problem. Chemical kinetics deals with the study of the speed of the reaction as well as the mechanism of the reaction. Chemical kinetics is a branch in physical chemistry which deals with the study of a rate of action, speed of a reaction, or velocity of a reaction. Not only it deals with the study of the speed of a reaction, but it also deals with the mechanism in which the reaction takes place. That's the branch in chemical kinetics. Now, we were learning in the previous class two types of reactions basically. One is inorganic reaction. The other one will be organic reactions. Now, these inorganic reactions are called as ionic reactions, and organic reactions are called as molecular reactions. Because in case of ionic reactions, the reaction takes place between ions. Therefore, it's ionic reactions. These ionic reactions are very fast reactions. It's called as instantaneous reactions. Very, very fast reactions. And for very fast reaction, it is impossible to find the rate. Impossible to find the rate of reaction. Rate of the reaction. But organic reactions are called as molecular reactions. These molecular reactions are generally slow reactions because the reaction takes place between the molecules. In slow reactions, we can determine the rate of a reaction. Rate of a reaction is defined as the ratio of change in concentration with respect to time. So how do we define rate of a reaction? We define rate of a reaction as change in concentration with respect to time. Now, this rate of a reaction is represented by a small letter r, rate of a reaction with respect to time, with respect to product. Now, when we say rate of reaction with respect to product, we know that if I consider this as the reaction, A is the reactant and B is the product. As the reactions proceed, what happens? The concentration of the reactant will decrease and the concentration of the product will increase. So rate with respect to product is defined as increase in concentration of the product with respect to time. This is how we define rate of a reaction with respect to product. And similarly, the rate of a reaction, concentration of the reactant, decrease in concentration of the reactant with respect to time. This is the formula, or this is the definition for rate of a reaction. Generally, it is defined as the ratio of change in concentration with respect to time. With respect to product, we call it as increase in concentration of the product with respect to time. And with respect to reactant, it is called as decrease in concentration of reactant with respect to time. So this rate of a reaction is represented as plus or minus dx by dt, or it is also represented as plus or minus dc by dt. This dx indicates change in concentration, dt indicates change in time. Or we can write dc is also nothing but change in concentration, dt is change in time. What does this plus signifies? Plus signifies increase in concentration of the product with respect to time. This plus sign signifying that this is called as rate equation. This is called as rate equation. So in the rate equation, plus signifies increase in concentration of the product with respect to time, and minus signifies decrease in concentration of the reactant with respect to time. So this is the rate equation, and this is with respect to the definition of the reaction. Now, what's the unit for rate of the reaction? Unit for rate of the reaction is concentration. Generally, we take it as mole per liter, mole per liter, mole per liter. And time is generally taken in terms of what? Seconds. So therefore, the unit for rate of a reaction is mole per liter per second. Or we also can write it as mole per decimeter cube per second. We can represent in any of these ways. Generally, time is taken in seconds. So this is the unit for rate of a reaction. Following?
Yes, sir.
Students, are you following, students?
Yes, sir.
Yeah.
Yes, sir.
So I'll erase this. We'll have to work out some problems. We'll erase this and we'll continue with other things. This is introduction because a few of them were not there in the last class. So with that intention, I just gave you the introduction. We worked few problems also in the last class. We'll continue with the working out of the problems and then the theory part of this chapter. Now, I'm very sure that you know how to define rate of a reaction and what are the plus and minus signifying the rate of a reaction. And also, you know what's the unit for rate of a reaction. So these things you know. Now, coming to the stoichiometry and the rate. How do you relate stoichiometry and the rate? We have dealt with this. Now, for understanding, we will learn one or two more reactions. Nitrogen is a gas. Hydrogen is also a gas, 3 moles of hydrogen. And when nitrogen and hydrogen is allowed to react, you get ammonia. This is also in gaseous state. Now, how do I define rate? Rate is defined as plus or minus dx by dt. Dx is change in concentration with respect to time. Now, reactant, we know that the concentration of the reactant has to decrease and the product concentration has to increase. This is how any reaction will take place. All right, now with respect to the concentration of the reactant, we write it as change in concentration of nitrogen with respect to time. D is a change in concentration of nitrogen with respect to time. Since there is a decrease, we write it as minus sign, which will be equal to decrease in concentration of hydrogen with respect to time. But you can see the coefficient is 3. Here the coefficient is 1. Since the coefficient is 3, we have to divide the rate by 3. Therefore, we will get it as 1 by 3 change in concentration of hydrogen with respect to time. But since hydrogen is also a reactant, it will be minus. And that will be equated to the product, the change in concentration of ammonia with respect to time. Now, ammonia is a product, therefore it is increasing, plus sign. But the coefficient of ammonia is 2, therefore we have to divide by the coefficient, so I write it as 1 by 2. So this is the rate equation or stoichiometric rate equation for this reaction. Similarly, if you write one more reaction, H2 plus I2 giving you 2HI. Assume that all are in gaseous state. Now, what will be the rate, stoichiometrical rate equation now for this? It will be minus change in concentration of hydrogen with respect to time. That will be equal to, coefficient is 1. If you don't divide it by 1, it makes no difference. It will be minus change in concentration of iodine with respect to time. That will be equal to change in concentration of hydrogen iodide with respect to time. But here you can see the coefficient is 2. Therefore, we have to divide it by 2. And this is a product. Therefore, what will be the sign given here? Plus. Did you follow this? Understood this?
Yes, sir.
Okay, we'll continue with few of the problems and then continue with the theory part. This equation, you have to know how do we write the stoichiometrical rate equations so that you can calculate the rate, concentrations, all that. Equilibrium concentration, all that we can calculate. We will learn that. All right. Now the question is, consider a reaction 2N2O5 giving you 4NO2 plus O2. Nitrogen pentoxide decomposes to give nitrogen dioxide and oxygen. This is the equation. In the reaction, NO2 is being formed at the rate of 0.0125 mole per liter per second. What is the rate of a reaction at this time? What is the rate of a reaction at this time? Now, stoichiometrical rate equation will be what? Minus 1 by 2 change in concentration of nitrogen pentoxide with respect to time. That will be equal to plus 1 by 4 change in concentration of nitrogen time plus, not plus, equal to plus 1 only, no, plus change in concentration of oxygen with respect to time. This is the stoichiometrical rate equation. Now, what is given in the question? They've given in the reaction, NO2 is being formed at the rate 0.0125. And they're asking you to calculate what is the rate at this time. So rate will be equal to 1 by 4 change in concentration of nitrogen dioxide with respect to time. Because in the question they've given, in the reaction, NO2 is being formed at the rate mole per decimeter cube. So what will be the rate of the reaction? It will be 1 by 4 into 0, because they've given you here rate of the, in the reaction, NO2 is being formed at the rate. They've given NO2 formation rate, that is 0.0125. So 1 by 4 into 0.0125 on simplification will be 0.0031 mole per liter per second. Therefore, the answer for this question is option B, 0.0031 mole per liter. Did you understand how did we work this problem? Students following?
Yes, sir.
Others?
Yes, sir.
Yes, yes. Yeah, good. Now coming to the next problem. For a reaction, R giving you product, R is a reactant and P is a product. The concentration of the reactant changes from 0.05 moles to 0.04 moles in 30 minutes. What will be the average rate in minutes? What will be the average rate in minutes? Now, average rate is given by the formula change in concentration. Change we also can represent it by delta. Instead of D, we can write it as delta. Change in concentration of the reactant with respect to change in time. Since we're talking about the reactant, we have to write it as what? Minus sign. The previous representation is also same. See, this also is same. Minus D. So here, delta. So delta stands for small change. D also stands for small change. Now, this small change is represented by minus of final concentration or initial concentration, sorry, a final concentration, R2 minus initial concentration. This R1 is the initial concentration, R2 is the final concentration, divided by, what is the change in time? They've given change in time to be 30. So it will be minus of final concentration is what? 0.04. 0.04 minus of 0.05 divided by 30. So on simplification, we will get the answer 0.01. Minus into minus becomes plus 0.01 divided by 30. That will be equal to 3.3 into 10 to the power minus 4 mole per mole per or molarity per minute. Time they've given in minutes here. So we will also take time in minutes. And you can see in the options also they've given in terms of minutes. Therefore, we will retain the time in terms of minutes itself. If in the options they've given time in seconds, so you have to convert minutes into seconds. Now this question, the answer is option 3, 3.3 to the power minus 4. Simple problem. Did you understand this? Change in concentration of the reactant is calculated by what? Initial concentration, that is R2. R2 will be what? The final concentration. R2 is what? Sorry, the final concentration minus R1. What is R1? This is, the square brackets indicates molar concentration. Square brackets indicates active mass. Otherwise, remember, this is called as what? Initial concentration. R1 will be called as initial concentration. R2 will be called as the final concentration. So initial concentration is 0.05 and the final concentration is 0.04. And why is this minus sign? Because we're talking with respect to reactant. Since the concentration of the reactant decreases, we have to represent it by what sign? The minus sign. So this minus sign should be there here. Okay. Followed with this?
Yes, sir.
Yes, sir.
The next question. Good. During the decomposition of hydrogen peroxide to give oxygen, 48 grams oxygen is formed per minute. 48 grams of oxygen is formed per minute at a certain point of time. The rate of formation of water, they're asking you, rate of formation of water at this point is. Now, decomposition of hydrogen peroxide, they have not given you the reaction. So you should remember hydrogen peroxide is H2O2. This H2O2 will decompose to form water and half a mole of oxygen. But you should remember in there is no fractions, reactants or the product. So what we do is we multiply the whole equation by 2. When you multiply the whole equation by 2, what we get is 2 moles of hydrogen peroxide gives 2 moles of water and 1 mole of oxygen. This is the equation, 1 mole of oxygen. Now you write the stoichiometrical rate equation. So I can write the rate equation will be minus of 1 by 2 into change in concentration of hydrogen peroxide with respect to time. That will be equal to plus 1 by 2 change in concentration of water with respect to time. And that also will be equal to plus change in concentration of oxygen with respect to time. If the coefficient of oxygen is 1, therefore I don't divide it by 1. It also remains the same. The question they're asking is to find, okay, before that, in the decomposition of hydrogen peroxide to give oxygen, 48 grams of oxygen is formed per minute at a certain point of time, 48 grams. The rate of formation of water they're asking. So the square brackets indicates concentration, not the weight. All right, the square brackets indicates concentrations, not the weight. But in the question, they've given the weight. Since they have given the weight in question, we can write rate of formation of oxygen. Rate of formation of oxygen is 48 grams per minute. That is what given. 48 grams of oxygen is formed per minute. We have written. That can be written as 48 divided by 32. How do you find number of moles? Number of moles is determined by the formula weight in grams by molecular mass. Oxygen molecular mass is O2, molecular representation is O2, molecular mass is 32. So if you divide that, it will be 1.5 moles per minute. So they have given in grams, we have converted in terms of concentration, 1.5 moles per minute. Now we understood the formation of oxygen, but the question is they're asking you the rate of formation of water. Since they're asking you rate of formation of water, now we can write, therefore, rate of formation of water, H2O, will be equal to, maybe we can write, it will be equal to plus 1 by 2 change in concentration of water with respect to time. That will be equal to, now I'm equating two equations here. What are the two equations I'm equating? In the question, they have not given anything with respect to reactant. They've given it with respect to product here, oxygen formation. So I'll equate these two equations. That'll be plus change in concentration of oxygen with respect to time. We know that change in concentration of oxygen with respect to time is what? 1.5 mole per minute. So I can write 1 by 2, that is plus change in concentration of water with respect to time is equal to 1.5 mole per minute. This is what we have found out here, mole per minute. So what will be the change in concentration of water, with respect to time? So this 2, if I multiply here, you will get, maybe we can write 2 into 1.5. This 2 I'm multiplying, cross multiplying, 1.5. So it will be equal to 3.0 mole per minute. So rate of formation of water is 3 moles per minute. So the answer for this question is option D. The answer for this question is option D. I hope that you followed with this. We were in a position to equate this. Now, assuming in a question, if they've given you rate of formation of, if they would have asked you to find the rate of formation or decomposition of hydrogen peroxide, what you would have done? You would have equated these two equations. Since they asked for water, we equated these two. If they would have asked for the rate of decomposition or dissociation or decomposition, would have equated these two equations. Are you following?
Yes, sir.
யாருக்கு புரியல? I mean, wouldn't understand?
Understood, sir.
But someone was telling in the background that I didn't understand. Ajay, followed or not?
Yes, sir. Understood, sir. Sorry, sir.
Who's that background? Who's that
Sir,
background?
background noises, sir.
Where's
Sir, my
that
mom,
background?
Sir, my mom, sir.
What she didn't understand?
Sorry, sir.
What she didn't
Sir,
understand?
she's talking on the phone, sir. Sorry, sir.
No, I thought she doesn't understand chemistry.
Sorry, sir.
Why do you want to disturb my class like this? Huh? All right. Joke. Huh? You got it?
Yes, sir.
All right, we'll continue. Others you followed?
Yes, sir.
Good. One more person. In a reaction, the next question, in a reaction, 2HI giving you H2 plus I2. The concentration of HI decreases from 0.5 mole to 0.4 mole per liter in 10 minutes. What is the rate of the reaction during this interval? Now they're asking you what's the rate of reaction during this interval. Now, how do I calculate the average rate or rate of a reaction? Average rate of a reaction is given as, now see this, the coefficient of hydrogen iodide is 2. Therefore, I write it as minus 1 by 2 change in concentration of hydrogen iodide with respect to time. Now, that is minus 1 by 2. Now, what is the change in concentration? Now, in order to understand the change in concentration, if you remember the first problem, what we worked today, that is final concentration, R2 minus R1 divided by what? Time, change in time, or delta T. So it will be minus 1 by 2 into 0.4 minus 0.5 divided by time. It's in 10 minutes. So it will be it will be 0.1 divided by 20. Be 0.005. That will be equal to 5 into 10 to the power minus 3 mole per minute. So therefore the answer for this question is option A, 5 into 10 to the power minus 3 mole per minute. Did you follow this, students? Simple problem. Simple problem. Followed? Students, are you there?
Yes, sir.
Yes, sir. Yes, sir.
Yeah, good. The next question. For a reaction 2N2O5 giving you 4NO2 plus O2, rate and rate constant. See, they've given you rate and rate constant. Rate is represented by small letter r. That is equal to 1.02 into 10 to the power minus 4 moles per liter per second. Now they've given you rate constant. This rate constant is represented by letter K. Now what is this rate constant? They've given the value again, it has 3.4 into 10 to the power minus 5 per second. Now for us to understand what is rate constant, if I give you a reaction A giving you product, remember the speed of the reaction will depend on concentration of the reactants. So if the reactants is more, the speed will be more. Rate is directly proportional to concentration of the reactant. Remember, the rate is directly proportional to the concentration of the reactants. Now, if you remove this proportionality sign, we give a proportionality constant. And this proportionality constant is called as rate constant, or it is also called as velocity constant. It's also called as velocity constant. Now, for this particular reaction, what's that they're asking? The concentration of N2O5 in mole per liter will be. Now, for this particular reaction, we can write, they've given you what? The rate they've given you, and also they've given you rate constant. So I can write rate is equal to rate constant into concentration of N2O5. This is what is the understanding. So what will be concentration of N2O5? The concentration of N2O5 will be rate divided by rate constant. What is rate? 1.02 into 10 to the power minus 4 mole per liter per second divided by, what's the rate constant value? That is 3.4 into 10 to the power minus 5 per second. So on simplification, the concentration, what we will get is 3.0 mole per liter. On simplification, we'll get 3.0 something mole per liter. Concentration is always in mole per liter. Here, they have not mentioned the unit. Don't worry about it. But the answer for this question is 3.0 mole per liter. Did you follow this relation? Did you understand this relation? Rate is equal to rate constant into concentrations of the reactants. Here, only one reactant we have. That is why we've written it like this. No problem with this?
Yes, sir.
Oh my God.
Yes, sir.
Yeah. The next question. For the reaction, again, it's a similar type of question, but not the same. We'll try to understand it. For the reaction N2O5 gas, giving you 2 NO2 in gaseous state plus half O2 in gaseous state. The value of rate of disappearance of N2O5 is given as 6.25 10 to the power minus 3 mole per liter per second. The rate of formation of NO2 and O2 is given respectively. They have asked you to find out the rate of formation of NO2 and O2. For that, you need to write the stoichiometrical equation, rate equation. What is that they've given? So N2O5, which is in gaseous state, it will decompose to form 2 NO2 in gaseous state plus half O2 in gaseous state. Half O2 in gaseous state. So how can we write this? Now, what will be the stoichiometrical rate equation for this? I can write minus of change in concentration of N2O5 divided by time. That will change in time. That will be equal to plus 1 by 2 change in concentration of NO2 divided by change in time. That will be equal to, see here, the stoichiometry is half here. So it will be plus of 1 divided by 1 by 2 change in concentration of oxygen with respect to time. So what I can write this as minus change in concentration of N2O5 divided by change in with respect to time. That will be equal to plus 1 by 2 change in concentration of NO2 with respect to time. That will be equal. What happens? 1 by 2 is how much? It will be plus 2 change in concentration of oxygen with respect to time. Did you understand this? Do you understand how I wrote it?
Yes, sir.
Yes. Now what they've asked,
Yes, sir.
they've given you rate of disappearance they've given you of N2O5, and they're asking you to find the formation. So what NO2 and O2 they've asked. Since they've asked NO2 and O2, we can equate these two equations. So when I equate these two equations, I can write minus change in concentration of N2O5 with respect to time is equal to plus 1 by 2 change in concentration of NO2 with respect to time. Now, since we want the formation of NO2, I can write this equation as change in concentration of NO2 with respect to time will be equal to what? Can I take it equated to the side twice? So it will be minus 2 into change in concentration of N2O5 divided by change in time. So what will be this? That will be equal to 2 into, what is the rate of disappearance of N2O5 they've given? The disappearance is 6.25 10 to the power minus 3. So it will be 6.25 into 10 to the power minus 3. That will be equal to 1.2 into 10 to the power minus 2. It's mathematics simplified. It will be mole per liter per second. See, you should ask me a question. What happened to this minus sign? What happened to this minus sign? Why I didn't write the minus sign? This minus sign indicates decrease in concentration. But here, NO2 is a product. So therefore, this minus sign they've ignored. So therefore, the rate of formation of NO2 is 1.2 into 10 to the power minus 2. Similarly, now we can equate these two equations because they've asked you to find the formation of oxygen also. If I have to equate these two equations, what do I get? Minus change in concentration of N2O5 with respect to time will be equal to 2 into change in concentration of oxygen with respect to time. So what will be this change in concentration of oxygen with respect to time will be what? Minus 1 by 2 into change in concentration of N2O5 divided by 2. Should I consider this minus sign or not now? Should I consider this minus sign or not? Should I consider this minus sign? NO2 is a product. Therefore, this minus sign will be what? Ignored. So,
No, sir, it's not considered.
it's ignored. Rate of decomposition of nitrogen pentoxide is what? 6.25 10 to the power minus 3 divided by 2. It will be 3.125 10 to the power minus 3 mole per liter per second. So answer option for this question is, what is the option for this question? Answer for this question. It is 1.2 into 10 to the power minus 2 and 3.125 into 10 to the power minus 3. Therefore, the option for this is option B, 1.25 into 10 to the power minus 2 mole per liter and 3.125 into 10 to the power minus 3 mole per liter. Clear?
Yes, sir.
Understood this? Yeah. Now, factors affecting the rate of a reaction. So, based on the first topic, stoichiometrical rate equation and rate of a reaction, we have worked enough of problems, different varieties of problems we have learned today. So, we'll continue with the theory part of the topic. Now, factors affecting rate of a reaction. What are the factors? In your 12th standard, they can ask you the factors. They will not ask you the explanations, but they will ask you the factors influencing the rate of a reaction. What are the factors influencing the rate of a reaction? The first one is nature of the reactant. The first factor is nature of the reactant. You can see here, gaseous state it's faster compared to liquid state, and liquid state is faster compared to the solid state. Physical state of the reactants. This has considerable effect over the rate of reaction. The first factor is nature of the reactant. We will learn further. Now, we will not be more specific in learning the particle size, all that. We will mention the terms and we will try to understand. The first one is nature of reactant. The second factor is concentration. Concentration. The third factor is temperature. The fourth factor is catalyst. The fifth factor is presence of sunlight. Presence of sunlight. What are the factors affecting the rate of reaction? The factors affecting the reaction is, the first one is the nature of the reactions. The second one is concentration. Third is temperature. Fourth is catalyst. And the fifth is sunlight. Fifth factor is sunlight. Now we will try to understand what is nature of reactant, what do you mean by that? Now there is a law called as law of mass action. This law of mass action is proposed by Goldberg and Weige, G-U-L-D-B-R-G, Goldberg and Weige. The nature of the name of the scientist who proposed this law of mass action. Law of mass action is represented as LMA. LMA. All right. Now, what is this law of mass action? We'll consider a reaction, A moles of A plus B moles of B, giving you C moles of C and D moles of D. This is the reaction. Okay. Now, according to law of mass action, what is the statement? First, we'll try to understand the statement. Now, in order to define law of mass action, we need to have a condition, that is at constant temperature. At constant temperature. The condition is constant temperature. At constant temperature, the rate of the reaction is directly proportional to product. In mathematics, product means what? Multiplication. In the mathematics, the product is what? Multiplication. Rate of a reaction is directly proportional to product of molar concentration of reactants. The square bracket indicates molar concentration. Where? What are the reactants here? Small letter A and not small A and what? B. So it will be concentration of A and concentration of B. Right. But you can see the coefficient is small letter A and B. The coefficients has to be raised to the power. This is law of mass action. What is law of mass action? At constant temperature, the rate of a reaction is directly proportional to product of molar concentration of reactants whose coefficients are raised to their power is called as law of mass action. Did you follow this law of mass action? Did you understand what is law of mass action?
Yes, sir.
What is the definition for law of mass action? At constant temperature, the speed of the reaction or the rate of the reaction is directly proportional to product of the molar concentrations of the reactants whose coefficients are raised to their power. So now from this law of mass action, we clearly understand that the speed of the reaction depends on concentration of the reactants. So if the concentration of reactants are more, the speed of reaction will be more. So this is what I just want you to remember. Now we will discuss each and every factor in detail. Okay. Now, I hope that you understood law of mass action. Students, others also followed. Ajay, did you follow this?
Yes, sir.
Yeah.
Yes, sir.
Yes. Oh, this is a 2-mark question in 12th standard. They can ask you, define or state law of mass action. All right. At constant temperature, the rate of a reaction is directly proportional to product of active masses or molar concentration of the reactants whose coefficients are raised to the power. Now, we are talking about factors influencing the rate of a reaction. Under that, we have learned the first factor influencing the rate of a reaction is the physical state. Now, gaseous reactants or gaseous reactions, reaction takes much faster compared to the liquid state of the reactants, and liquid state of the reactant takes much faster compared to the solid state. This is what we have learned with respect to the physical state. Now, coming to the chemical state, the first one is nature of reactant. In this, we can write ionic reactions are faster. Ionic reactions are faster, and molecular reaction. We learned today also this one, I told you, molecular reactions are slow. So, if the reaction is taking place between ions, then the reaction rate is what? Faster. If the reaction is taking place between molecules, then the reaction is slow. Because in case of molecules, the bonds have to break, the old bonds have to break, the new bonds have to form. For those reasons, the are generally slow. Ionic reactions, there is only force of attraction between the oppositely charged ions. Therefore, the reaction will take faster in case of molecular reactions. All right. In case of ionic reactions, do you understand?
Yes, sir.
Yes, sir.
Yes. Now, coming to the concentration. The second factor is concentration. Now, assume the place where you are sitting is the container. In that container, we have one oxygen molecule and one nitrogen molecule. So the room you're sitting is very big, and the molecules are very, very small. All right. So what happens? Only one nitrogen molecule and one oxygen molecule is there. What is the possibility for them to react? The possibility for them to react will be more or less. What will be the possibility for them to react? Will it be more or less? Students, are you there?
Sir.
Yeah, tell me. What will be the possibility for them to react? Will it be
Sir,
more
less,
or less?
Sir, less, sir.
Less, because the volume of the container is very large, and I have only one nitrogen molecule and one oxygen molecule. So for them to react to form nitrogen dioxide, N2 plus O2, they react to give NO is very, very less. But assume if there are thousands of nitrogen molecules and thousands of oxygen molecules in the same container where you're sitting in the room, many number of oxygen, thousands and thousands of oxygen and nitrogen, what will be the possibility for them to react? What will be the possibility for them to react? Will it be more or less? Students participate.
So,
Will it be
sir,
more or less?
so more, sir.
If you have more nitrogen and more oxygen, will it be possible for the nitrogen and oxygen to collide easily or not?
Yes, sir.
Because more number, just imagine in a market where the population is very, very less, very few number of people are there. Okay, when two people are walking, just as in a market, two people are walking, will they hit each other? Will they bang each other? No. But if there is hundreds and hundreds of people crowding in a market, what happens? It will be difficult for us to walk also. That means people will collide each other. Yes or no?
Yes, sir.
Yes. Similarly, when you have only one nitrogen and one oxygen, the possibility for them to collide is less. But you have more number of nitrogen and more number of oxygen. We have thousands of nitrogen and thousands of oxygen. That means concentration is more. So nitrogen to collide with oxygen becomes what? More frequent. Therefore, the product formation will be what? Faster. That means the rate of a reaction is directly proportional to concentration. We have learned law of mass action. Remember, law of mass action clearly states at constant temperature, rate of a reaction is directly proportional to concentration. So I can write concentration is directly proportional to the rate. The third factor is temperature. The third factor is temperature. What happens when you increase the temperature? When you increase the temperature, the molecules will gain more of kinetic energy. When the molecule gain more of kinetic energy, what happens? They will collide the reactants, collide each other with much energy. Therefore, products formed will be what? More. So temperature, increase in temperature is also increasing the rate of reaction. Therefore, I can write a rate is directly proportional to what? The temperature. A temperature is directly proportional to the rate of a reaction. The fourth factor is catalyst. Now, catalyst, what is catalyst? It's a chemical substance which alters the rate of reaction. Generally, catalyst is used to increase the rate of reaction. So, presence of catalyst is the catalyst also will increase the rate of the reaction. Right? There is something called inhibitors. All right. The opposite of catalyst is inhibitors. What is this inhibitors? It will slow down the reaction. Slow down the reaction. Example for an inhibitor is glycerol. Remember, there are more number of examples for catalyst. Iron is a catalyst, nickel is a catalyst, benzoyl peroxide is a catalyst, hydrogen peroxide is also a catalyst. Right? So catalyst also will increase the speed of reaction. The next is presence of sunlight. Presence of sunlight. This presence of sunlight. Now this also, sunlight is also a form of energy, heat energy, H nu, E is equal to H nu. So this also will increase the rate of reaction. On the surface of water, we have hydrogen and chlorine. This is called as photochemical reaction. This hydrogen and chlorine will not react in the dark, the night, no sunlight is there. But in the daytime, they will react with each other to form hydrogen chloride on the surface of water. So sunlight, presence of sunlight also will increase the speed of the reaction. Now, do you understand the factors influencing the rate of reaction? One is the nature of the reactant, the second is concentration, third is temperature, fourth is catalyst, and the fifth is presence of sunlight. Did you follow this? Now,
Yes, sir.
we have dealt it. Now, there is a lot of theory part here they've given. A physical size of the reactants. Amongst the solids, rate increases with decrease in size of the solid. These are for competitive exams. You should remember. In case of solid reactants, as the size of the reactant decreases, solid reactant decreases, rate of reaction increases. Because when size of the particles increases, it means surface area of the particle increases. When the surface area of the particle increases, the rate of reaction increases. The next is chemical nature. Chemical nature of the reactant. So reaction involving polar and ionic substance, including the proton transfer reactions, are very fast. Just now we learned. On the other hand, reaction in which bonds are rearranged, that is molecular reaction. These are molecular reactions. Molecular reactions are very slow. I taught you this. Now, next is type of reaction here. See, oxidation and reduction reaction, which involve transfer of electrons, are also slow as compared to ionic reaction. So redox reaction is slow. Redox reaction is slow compared to ionic reactions. Ionic reactions are fast, redox reactions are slow. Next, substitution reactions are relatively much slower. Substitution reactions are relatively much slower. Now, for an example, methane, when allowed to react with chlorine in the presence of sunlight, we will get methyl chloride and HCl. I have learned it in 11th standard, chlorination of methane. Halogenation. This is an example for substitution reaction. One of the hydrogen is replaced by one chlorine. So substitution reactions are generally slow. Effect of temperature, I told you. The rate of chemical reaction generally increases on increasing temperature. The rate of reaction becomes almost double or triple in 10-degree rise in temperature. This we will learn it as a separate topic called as temperature coefficient. Temperature coefficient. We will learn this later stages. Now see at the statement you remember here. As you increase the temperature, what happens? Rate of reaction increases. And also you see here, when you increase the temperature by 10 degrees, the speed doubles or the speed triples, right? So that is called as temperature coefficient. We will learn as a separate definition and some numericals also based on this little later. Oh, they've given you the formula. We'll finish off here itself. Temperature coefficient of the reaction is defined as the ratio of rate constant at T plus 10 degrees Celsius divided by T degrees Celsius. This is called as temperature coefficient. Now T plus 10 degrees, example, a reaction A plus B giving you C. This reaction at 25 degrees Celsius, assume that it takes 100 minutes. How many minutes this takes? 100 minutes. A plus B giving you C at 25 degrees Celsius, it takes 100 minutes. The same reaction, if you perform at 35 degrees Celsius, the reaction will be completed in 50 minutes. That means we are increasing the temperature by 10 degrees. The speed of reaction doubles. This is called as temperature coefficient. So temperature coefficient is defined as the ratio of rate constant of a reaction at a particular temperature divided by rate constant of a reaction 10 degrees lower to it. So this is rate constant 35 degrees Celsius. Here the rate constant is 25 degrees Celsius. Did you follow? Temperature coefficient, did you follow?
Yes, sir.
My next is concentration of the reactants. So the concentration of the reaction I clearly explained. As the concentration increases, the rate of the reaction increases. The rate of a chemical reaction is directly proportional to concentration of the reactant, meaning decreases with the decrease in concentration. Or we can write what? Rate of a reaction increases with increase in concentration. I wrote earlier, rate is directly proportional to concentration. I wrote, when I was explaining the factors, I wrote here, if you can, I don't know whether it's there. You can see the rate is directly proportional to concentration. I wrote it here. All right. The next one is temperature. We learned temperature coefficient. We learned presence of a catalyst. We have a separate topic to be learned with the effect of catalyst, but I clearly told you catalyst will increase what? The speed of the reaction. See, there is explanation given here. The function of catalyst is to lower the activation energy. Greater the decrease in activation energy caused by the catalyst, higher will be the rate of reaction. What is activation energy, normal energy, threshold energy? All that we'll have to learn later. For now, you remember catalyst increases the rate of the reaction. Catalyst will increase the speed of the reaction. All right, and we learned presence of sunlight here. There's many chemical reactions whose rate is influenced by radiation, particularly by UV light and the visible light. Such reactions are called as photochemical reaction. I explained. Example: photosynthesis, photography, blueprinting, photochemical synthesis. I told you photochemical synthesis. Just now I gave you an example. All this happens in the presence of sunlight. All right, these are called as photochemical reactions. So presence of sunlight also will increase the rate of the reaction. The radiant energy initiates the chemical reaction by supplying the necessary activation energy required. Now, so we have learned the factors influencing the rate of a reaction, right? The next topic is law. I explained it to you, but anyways, now in this factors affecting, I have only a direct explanation. One of the question here is the rate constant of reaction depends on temperature of the reaction, the extent of the reaction, initial concentration of the reactants, the time of completion of reactants. Rate constant of a reaction depends on temperature of the reaction, extent of the reaction, initial concentration of the reactant, time of reaction. See, rate is directly proportional to concentration of A into concentration of B. If I consider this as a reaction, A plus B giving you product, if I consider, this is what? The rate of reaction. Rate depends on concentration. The question here is rate constant. So rate constant always depends on temperature. Remember, rate constant will depend on the temperature of the reaction. So the answer for this question is temperature of the reaction. Remember, it is not rate. Rate depends on concentration of the reactants. Now, rate constant always depends on temperature. Did you follow this?
Yes, sir.
Yeah. Now, we'll have to consider law of mass action also we have done. The mathematical representation units have to tell you, and the rate law, all that, we'll have to continue. Tomorrow we'll continue with the class, all right? With some of the numericals that for tomorrow. Ma'am?
Yes, sir. Thank you, sir.
Bye, ma'am. Bye, ma'am.
Okay,
Bye.
sir. Bye, sir.
Thank you, sir.
Bye.
Thank you.